All right, so if we take a look at this, this is page 11 out of the yellow packet. Very similar to what the quiz is going to look like. We've got the compound beryllium dichloride, and here we get a little note: beryllium's happy with just 4 valence electrons, unlike most elements. So first we're going to figure out how many electrons we would love to have, and we have 1 beryllium, and beryllium, as we just noted, is unlike most things, and beryllium's happy with just 4. And then we're going to add to that how many would make chlorine happy, and there's 2 chlorines. Chlorine would be happy with 8 valence electrons, so that's going to give us a total of 20. Now we back into the reality in the real world. Beryllium only has 2 valence electrons because it's in group 2, and chlorine actually has 7 valence electrons because it's in group 17. So 14 plus 2 is going to give us 16. Now we do a little subtraction here. 20 minus 16 is going to give us 4. 4 electrons need to be shared. Divide that by 2. That'll tell us how many bonds we need. So 2 bonds. So we're going to put beryllium in the middle. Usually the elements that are further to the upper left on the periodic table are in the middle. And we're going to put a chlorine on either side. And we're going to connect them with single bonds. And we compare how many bonds we just drew to how many bonds that our formula told us we should have. And it turns out to be the same. So we don't need to add any bonds. We're good. Now we're going to go around making sure everything is happy. So we said beryllium wanted 4 electrons. Right now this thinks it has 2 from this bond and 2 from this bond, so it's good. And then the chlorines each want to have 8 valence electrons. So this chlorine thinks it has 2 from this one, so we need 3, 4, 5, 6, 7, and 8. And then this chlorine thinks it has 2 from this bond, so we need to add 1, 2, 3, 4, 5, 6, and then our 7 and 8 from the bond. All right, so for our ABE notation, we just look at our central atom that we're going to call A. And beryllium is attached to 2 other atoms, so we'll call that AB2. And we don't have any dots or pairs of dots on beryllium, so we don't need to worry about the E part. So AB2 would be our ABE notation for beryllium dichloride. Now for our shape, we look up on the back of this page, or actually the next page in your yellow packet, there's a flow chart, as well as ABE notations and their corresponding shape. If we look up AB2, it finds that this is linear. And for polarity, we use the periodic table we got in class that has electronegativity. So we looked at this. The only types of bonds that we have are connecting beryllium to chlorine. Beryllium has an electronegativity of 1.5, and chlorine has an electronegativity of 3.0. So we always subtract the smaller from the bigger, even though I wrote it the other way around. So this will give us a difference in electronegativity of 1.5. And right above, or right below the ABE notations, there's a thing that tells you the differences in the ranges for electronegativity. So we find that 1.5 falls into the polar range. But if we go through the flowchart that's right below that, the first question is there a polar bond? We would say yes, because this is a polar bond. The next question would say, are there lone pair electrons on our central atom? It says, well, we don't. And then the next question asks, is the central atom bound to 2 different elements? Well, it's bound to 2 different atoms, but they're of the same element. So the answer to that question is no. So that makes this compound nonpolar. So that's how you would do these. I'll do the next one all the way through in the next video, but then we'll just put the answers up. So if you need to go back to figure out how to do these, you just listen to this video again or the next video.